Hey everyone, and welcome. Today we are diving deep into object communication in Unity. And look, if you're prepping for that certification exam, you're gonna want to stick around because we are covering the exact rules and performance traps that you'll be tested on. So let's just get right into it. This is really the core question that separates a beginner from a pro, right? Answering it correctly isn't just about making your game work, it's about making it work efficiently. And you can absolutely bet this whole concept is going to be all over your certification exam. Okay, so here is our game plan for today. First, we're going to look at your local toolbox. Then we'll move on to talking to the family. After that, we'll cover the global search party, then tag your it, and finally, we'll wrap it all up with an exam challenge to make sure you've got it down. All right, let's kick things off at square one. We're talking about scripts talking to their neighbors right there on the very same game object. This is going to be your most common and, honestly, when you do it right, the fastest way for things to communicate in Unity. So, this is your number one tool for the job, GetComponent. All it does is look on its own game object for another component. You know, like a script asking for the rigid body so it can apply some force. It sounds super straightforward, right? But its simplicity actually hides a major performance trap. And this brings us to what I call the golden rule. Seriously, this is the single most important thing you need to burn into your memory, not just for the exam, but for your whole career. And it's simple. Never search for the same component more than once, if you can possibly avoid it. And here's exactly why this matters so much. On the left, you see GetComponent being called inside update, so every single frame. This is just a performance nightmare, pure and simple. The right way, over on the right, is to find it just once, usually in awake or start, and then just store it in a variable. We call this caching, and trust me, it is absolutely essential. But wait, there's more. Unity has actually given us an even better tool. See, if the old GetComponent fails to find something, it can create a tiny bit of temporary data. We call this garbage, that the system has to clean up later. But the modern standard, TryGetComponent, it's designed for what we call zero allocation. It just returns true or false without making any mess at all. So, pro tip for the exam, if you need to check for a component that might not be there, TryGetComponent is always the best answer. Okay, so let's build on that foundation. We're now going to expand our search beyond just a single object. I mean, what if a script on a car's wheel needs to talk to the engine script on the main car body? Well, for that, we've got to search the family tree. So this is how GetComponent in children works. First, it checks itself. Then it dives all the way down one branch of its children, looking for what it needs. If it doesn't find it, it comes back up and tries the next branch. But, and this is the key takeaway, it stops the second it finds the very first match. But here's a classic exam trap. You have to watch out for this one. If any game object in that chain is inactive, unchecked in the inspector, the search just hits a brick wall. The component you're looking for might be on a grandchild, but if its parent object is inactive, Unity just won't find it, unless you specifically tell it to look in inactive objects. And of course, we can go the other way, right? With GetComponent in parent. This is perfect for when a little piece of a bigger object, say a foot collider, needs to tell the main character's health script, hey, I just took damage. It searches itself first, then its parent, then its grandparent, all the way up the hierarchy. All right, now we're zooming all the way out. These next methods, they don't just search a family tree. Nope. They search every single object in your entire scene. Now, they are powerful, for sure, but they are incredibly dangerous from a performance standpoint. Seriously, you should think of these as the nuclear option. And the exam loves to test you on this next method. Why? Because using it incorrectly is one of the fastest ways to bring your game grinding to a halt. Meet GameObject.Find. This thing literally goes through every single object in your scene, one by one, comparing its name to the string you gave it. Can you even imagine doing that every single frame? It's unbelievably slow, and honestly, it should almost never be used. So, for your exam, think of this as a freebie. I'm serious. If you see a question that shows GameObject.Find being called inside an update loop, that choice is guaranteed to be the wrong answer for any performance question. It causes huge game-breaking lag. End of story. Now, find has a couple of relatives you should know about. Find with tag is a little faster, sure, because Unity keeps an optimized list of tags, but it's still a scene-wide search. Then there's find object of type, which is also really slow since it has to check the components on every object to find a match. Look, these are okay to use maybe once in a wake to find a unique manager or something, but that's it. Okay, so let's say you found an object, maybe through a collision. Now you need to identify it. Is it a player? An enemy? A wall? Well, how you ask that question matters a whole lot for optimization. And you guessed it, it's on the exam. And here is the crucial difference. When you use other.tag equals player, you're basically forcing C# to create a whole new piece of string data in memory just for that one comparison. Now, do that thousands of times a second, and you're creating a ton of garbage that the system has to clean up, which can cause those annoying stutters in your game. CompareTag, on the other hand, is an optimized internal Unity function that does the check without creating any garbage at all. So the rule is simple. Always choose CompareTag. All right, let's put these rules to the test, shall we? I've got some real exam-style questions lined up. It's time to see if you can spot the most optimized solution when you're under pressure. Okay, first scenario. Imagine a bullet hits an object. We're firing tons of these things, so performance is absolutely critical. You have to check for an eye-damageable interface to apply damage. The question is, which approach causes the least amount of garbage collection? Okay, let's look at the options. A is your basic GetComponent. B is checking the tag. C uses that TryComponent method we talked about, and D is SendMessage. So, which one is the cleanest? I'll give you a second to think about it. And the correct answer is C. TryComponent is the one. It's explicitly designed for zero allocation retrieval, which makes it the most optimized choice here. It's the king for high-frequency events like this. All right, next up, this question is all about that hierarchy search and the inactive objects trap we talked about. So a script on a chassis object calls getComponent within children T, but the parent wheels object is inactive. What happens? So your options are A, it finds the tire anyway, B, it returns null, C, it throws an exception, or D, it finds the tire only if the tire itself is active. What do you think? The answer here is B, it returns null. This is that inactive object trap in action. The search hits the deactivated wheels object and just stops. It can't go any further down the chain. Okay, final question. Let's circle back to identification. We already know that CompareTag player is preferred over GameObject.Tag equals player. But why? The exam will want you to know the reason. So is it A, because it uses physics layers, B, because it allows partial matching, C, because it avoids allocating new string memory, or D, is it just a style preference? Think about what's happening under the hood. And the correct answer is C. It avoids allocating new string memory. Remember, the .tag property creates a new C# string, and that causes garbage. CompareTag avoids that allocation entirely. It's cleaner, it's faster, and it's the right answer on the exam every single time. So you now know the rules of engagement. You know to cache your components, to favor TryComponent and CompareTag, and to be very careful with those global find methods. So the real question is, armed with all this, what's the first thing you're going to go optimize in your own project?